Hey team, it's Mr. Z, and last time we were dilating a function by a factor of x. We're going to go ahead and look into it deeper and see how we could figure this out. So let's go ahead and dive on in. So basically last time we took two pieces of information. We took our x and we took our y, and then we got our new function. I'm going to say f apostrophe x. It could be f prime, but I'm going to let it be the new version of the y coordinate. That's because, for example, at our light blue point, 0, it was 3, but then it became 0. At our other point, notice what happened. It was negative 1. That point is at 2, and then it became negative 2. Notice a trend, folks. You're multiplying the x times the f of x to get the new y part of the coordinate. If I were to continue, and I would say negative 2. Graphically, looking at my graph, I see that the y value of negative 2 is 1. Negative 2 times 1 is going to be negative 2. So this new point would be here. Let's continue. So I would go ahead and pick the next point, negative 3. Negative 3 on my graph is at the y value of 0. So when I multiply them, this point is going to be the same. If I were to continue, let's go ahead and say negative 4. The y value would be negative 1. The product of these two would be a positive 4, making my input negative 4 and my output positive 4. So this would result in 1, 2, 3, 4. The graph is starting to form. The idea is that it's going to look something like so. Okay, so it looks like a quadratic. It looks like a quadratic that has concavity being concave up. So what is the equation of this new function? Well, this is the math part. This is where we excel. G of x is going to be equal to x times f of x. What is the rule of f of x? Well, what are we talking about? X plus 3. Multiplying this out, this means that I'm going to go ahead and distribute x to x and positive 3, resulting in x squared plus 3x. Notice how it's a quadratic, and from this we can go ahead and know that this is in standard form. So basically, if I wanted to write it in standard form to the side, g of x would be 1x squared plus, I forgot the x, 3x plus 0. Okay, so how did the dilation change the degree of the new function? The dilation increased the degree to 2 as a result of multiplying by x. Identify the zeros of g of x. How are these related to the two linear factors x plus 3, and x. Okay, so continuing on, I can see my graph has two zeros at -3, at 0. Okay, these two zeros. Notice with x plus 3, and then we had x. Well, how are these related to the two linear factors x plus 3 and x on our graph? These are the zeros, which are also known as the x-intercepts. They're also solutions of the zero product property. Take this, folks. We are solving g of x equals x squared plus 3x. This is what we're dealing with. 0 equals x times x plus 3. This form enables me to easily see, hey, what number makes this 0? Well, 0. Solution 1, x is 0. Solution 2 is going to be, hey, what number makes x plus 3 0? Well, x equals -3. So the idea behind both of these is that the zeros are still zeros after multiplying.